Hi, this is Cameron Yuki. We'll be going over AP Calculus AB 2013, Question 1. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by g of t equals 90 plus 45 cosine of t squared over 18, where t is measured in hours and 0 is less than or equal to t is less than or equal to 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, 0 is less than or equal to t is less than or equal to 8. The plant processes gravel at a constant rate of 100 tons per hour. Alright, let's get started. Part A states, find g prime of 5. Using correct units, interpret your answer in the context of the problem. So some skills we're going to use, pretty much just basic differentiation, and then we're going to plug in 5. So let's get started. We'll take the derivative of g of t. And remember chain row. And the next step would be to plug in 5 for t. Once we've got that, we're going to plug it into our calculator and get negative 24.588. So in the context of the problem, this gives us the rate at which gravel is arriving in, and that is decreasing by 24.588 tons per hour at time t equals 5. So we're going to write that in our answer. I just printed it out. So the points awarded here are for g prime of 5, which is this answer right here. So that's 1 point. And then another point is the explanation. That's another point. Moving on to part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Skills we'll use include definite integration. We'll also use the original equation as well as the interval 0 to 8. So we'll start by using the integral to find the total amount from 0 to 8, the hours of operation of g of t. So that'll give us the total amount. This looks like this. Okay, so since this problem allows the use of a calculator, we will just plug it in to find the total amount, and that looks like this. So for those of you using TI-89, so like none of you, we'll use the integral function and just plug this in. In terms of t from 0 to 8. So by calculating, that'll give us 825.551 tons. So the way points are awarded here are first using an integral to solve, and then also the correct answer, 825.551 tons. Let's begin part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at the time t equals 5 hours? Show the work that leads to your answer. Recall that g of t is the function of the rate that gravel is arriving at the facility. And also recall that the rate that gravel is being processed is 100 tons per hour. So to answer the question, we have to compare the rate at which gravel is arriving versus the rate at which gravel is being processed. And this is at t equals 5 hours. So we want to plug in g of 5, or 5 to function g, and that is so plugging that into the calculator, we're going to get the answer 98.141 approximately. So when we compare that to P of 5, which is just 100, the value for G is less than 100. So G of 5 is less than 100. And that tells us that at time t, the rate at which unprocessed gravel is arriving is less than the rate at which it is being processed. Therefore, the amount of unprocessed gravel at the plant is decreasing at time t equals 5. So, the way points are awarded here are... I erased it. Plugging in 5 into the equation, which gave us 98.141 approximately. And that comparison to 100 tons per hour, the rate at which it's being processed. So that's 1 point there. And also the explanation, which is printed here. Let's begin part D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. Some skills we use include applications of derivatives and applications of integrals. So let's begin. Here we'll need the original equation, or the function g of t, and the definite interval 0 to 8. So, to find the total amount of unprocessed gravel at the plant at any given time t, we have to include 500, the amount of unprocessed gravel at the beginning of the workday, plus the integral from 0 to t time of g of t, which is the amount of gravel arriving at the facility, minus 100, the amount of gravel leaving the facility, or being processed at the facility. And then, to find the critical points, we have to take the derivative of a of t, and that is g of t minus 100, and we set that equal to 0. We can do this in our calculator by putting in 90 plus 45 cosine t squared of 18 over 18 minus 100, and we set that equal to, we graph it, and we also graph y equals 0, and we find out where this function intersects y equals 0. So it turns out there's one critical point on the interval 0 to 8, and that is at t equals 4.923. Okay. So once we get that value, we plug it into the table, which will act as the justification for the answer. We have to remember to plug in the endpoints, 0 and 8, because it's a definite interval. So plug in 0, 4.923, and 8. So we plug these values into A of t right here. When we plug in 0, we get 500 tons. When we plug in 4.923, we get 635.376 tons. When we plug in 8 for time, we get 525.551 tons. So, as we can see in the table, when we plug in 4.923, we get the greatest amount, which is 635.376 tons. And that is our answer. Points are awarded for the consideration of a prime of t, right here, and setting that equal to 0 to find the critical points. Also, the answer, 635.376 tons, and the justification, which is this table, because we compared the endpoints and the critical points and found out which one gave us the greatest value. And that is it for question 1 on the Calculus AB exam 2013. Thank you.